Hey everyone, welcome to hok'stutoring. Hope you're having a great day. Today we are doing question 15 from chapter 13D. So your static dynamics chapter, and more specifically, it is your connected particles topic. Right, so let's get into the question. Question 15, this is the last question of this subtopic. So, if you're struggling with this question, hopefully this video helps you out. So let's get into it. 15. A particle of mass 3 kg rests on a rough horizontal surface, meaning there is friction. So that's your 3 kg mass right here. The particle is attached by a light inextensible string passing over a smooth fixed pulley to a particle of mass 4.2 kilograms, this particle right here, on a smooth inclined plane at an angle of theta degrees to the horizontal, where sine theta is 0.6. Okay, so we know the horizontal surface is rough, so there is some coefficient of friction. We don't know for sure, but for now we'll just put a question mark there. And this inclined plane is a smooth plane, so there is no friction on this one, but there is friction on this other one. So it's an interesting question. Friction doesn't exist for both of the planes. All right. When the system is released from rest, each particle moves at an acceleration of 2 meters per second square. Okay, so we know acceleration is 2. Unlike most questions, you're not asked to find acceleration for this one. We need to find tension, and we also need to find coefficient of friction. So let's label everything in this diagram first. We know that there must be acceleration of 2 meters per second square. Now, where is acceleration? Where's the direction? Is it going to the right, going to this side, or is it going down the inclined plane? Well, it's pretty obvious, guys. Just use logic, use common sense. This object right here cannot move by itself to the right. There's nothing pulling it to the right. This one, on the other hand, gravity is trying to pull it down the inclined plane. So the only motion, the only possible direction of motion is going down the inclined plane. Okay, it's pretty obvious right there. Okay, so that's what acceleration is, and we are trying to solve for it. What is acceleration equals to? So let's label all our forces. Right, on this 3 kilograms, we've got our weight force, which is 3g. Weight force is m times g, and then obviously you also have your reaction force. Reaction force, once again, is perpendicular to the plane, which in this case just happens to be opposite to your weight force. And we know this object is not going to fly up the plane or down the plane, so reaction force or normal force, depending on how you want to call it, must be the same as your weight force in this scenario. Okay, so that's 3g. Okay, let's look at the 4.2 kilograms object. We've got the weight force trying to pull it down, so that is 4.2g. That's your weight force. And remember, whenever you are on the inclined plane, you need to draw your invisible triangle right here, okay? So perpendicular, the angle is also theta, so that you can find this horizontal force and that vertical force. This is the horizontal force that's pulling the object down the plane, so going in that direction, okay? So you need to find what the magnitude of that force is. And you've got a triangle, the magnitude of the hypotenuse of this triangle is 4.2g. So therefore, just using a little bit of trig, the horizontal force right here going this direction must be 4.2g sine theta, and that's the reason why they told you sine theta 0.6, so you can immediately tell, sine theta 0.6, I just multiply 4.2g, I get my horizontal force. That's pretty much it, okay, in labeling your diagram. You can also label reaction force over here, which I forgot, but yeah, once again, if you want to find reaction force, it's always the same as the one opposite of it, which is the vertical force over here, the perpendicular force, and that is 4.2g. Now this is sine, that would have to be cos theta, okay? So reaction force is also 4.2g cos theta. The reason why it's the same as this is so that, the forces balances out vertically so that it doesn't fly up or down the plane. That's it, okay? So now that you've got that all sorted, we can go answer the question. Part A, okay? What does part A ask us? Find the tension of the string. All right, so where's tension? Well, that is right here. See these forces right there? They're just on the strings, right? So it's pretty obvious tension's over there. If you want to find the tension force, we look at the object on the left. This one's probably, we know more of the variables. We know more of the constants. Whereas the object on the right, we know there is tension, but then there's also friction going the opposite direction, which unfortunately we don't know because we don't know what mu is, what coefficient of friction is, right? So let's solve for the objects on the left. Okay, so what are the forces affecting this? Well, there's tension going up the plane, but then horizontally going down the plane, there's a 4.2g sine theta, okay? You don't need to worry about reaction force and this 4.2g cos theta here because they balance out, it's not moving the object. Right, so Newton's second law of motion, if we apply it, F equals ma, resultant force, we have to find which one's the bigger force, which one's the small force. Since acceleration, we know the direction is going down the plane, then this force horizontally down the plane must be bigger than tension. So you start off with that. 4.2 g sine theta minus tension equals to the mass, which is also 4.2, multiplied by acceleration, which we know is equals to 2. Okay, so that's what we know. I'll write that down properly. Okay, so acceleration is equals to 2. Right, now 4.2 g, I can replace sine theta with 0.6, and then we are just finding tension, so that's 4.2 times 2, that's 8.4. Guys, you put in your calculator, just do some quick maths, and your answer for this one should be 16.296 Newton. Okay, so that's how you answer part A. Just solve for the left-hand side. Really, what's your object over here? What are the forces? You can easily solve for tension. Now, part B, guys. Now we look at this other one, so the one that has friction, right? Part B, find the coefficient of friction between the horizontal surface and the particle of mass 3 kilograms. So once again, use your Newton's second law of motion. This is our favorite formula, FAM, right? F equals AM, F equals MA. Resultant force, we need to find which one's the bigger force. Obviously in this case, we know the object, both of them are going down the inclined plane. So the force going left must be bigger than the force going right. And on this object right here, tension is bigger than friction, so it's T minus Fr equals to Ma. Okay, that's it. So tension we know is 16.296 because tension must be the same. It's a one string, so they must have the same tension, same entity. Okay, and then minus friction. What do we know about friction? Friction is coefficient of friction, mu, multiplied by the reaction force. So we don't know what mu is, but we know our reaction force is 3g. It's the same as your weight force. So multiply by 3g, and it's equals to mass, which is 3, and we know acceleration is 2. Guys, once you get this down, just simplify it a little bit, and 3g mu equals to 6. All you need to do now is solve for coefficient of friction, which if check inside your calculator again, you should get 0.35 approximately. Okay? So guys, that's it for question 15, chapter 13D. Nothing too hard. It's just your scenario here is a little bit interesting. You've got a rough plane, but then you also got a smooth plane. Yeah, but aside from that, guys, hopefully you found this video useful. If you did, please leave a like, and I guess I'll see you in the next video. See ya!